Venus, our closest planetary neighbour, is a strange and hostile world. It's often referred to as Earth's evil twin because it's similar in size and composition to our planet, but that's where the similarities end. One of the most bizarre things about Venus is its day-night cycle. You see, a day on Venus is actually longer than its year. I know it sounds crazy, but it's true. A day on Venus, the time it takes for the planet to rotate once on its axis, is about 243 Earth days. However, Venus takes only about 225 Earth days to complete one orbit around the Sun, which is what we define as a year. So how is this possible? Well, Venus rotates on its axis very slowly and in the opposite direction to most planets in our solar system, including Earth. This retrograde rotation means that the Sun rises in the west and sets in the east on Venus. The slow rotation also contributes to Venus's extreme temperatures. Because the same side of the planet faces the Sun for so long, the surface heats up to an incredible 900 degrees Fahrenheit, making it the hottest planet in our solar system. Neutron stars are some of the most extreme objects in the universe. They're born from the death throes of massive stars that have gone supernova, exploding violently and leaving behind these incredibly dense remnants. Imagine a star more massive than our Sun crammed into a sphere the size of a city. That's how dense a neutron star is. Now, these cosmic spinners are not just incredibly dense, but they also rotate incredibly fast. Some neutron stars, known as pulsars, can spin at a rate of up to 600 rotations per second. That's faster than the blades of a kitchen blender. This rapid rotation is caused by the conservation of angular momentum. When a massive star collapses into a neutron star, its rotation rate increases dramatically, like a figure skater pulling their arms in during a spin. These pulsars emit beams of radiation from their magnetic poles, and as they spin, these beams sweep across space like cosmic lighthouses. Mars, the red planet, is home to some pretty impressive geological features, including the largest volcano in our solar system, Olympus Mons. This behemoth of a volcano dwarfs anything we have here on Earth. Just how big is Olympus Mons? Well, it's about the size of the state of Arizona, with a diameter of roughly 374 miles. That means you could fit the entire Los Angeles basin inside its caldera, the bowl-shaped depression, at the volcano's summit. And if you were standing at the base of Olympus Mons, its summit would be so high that it would disappear into the Martian clouds. This massive volcano was able to grow to such an enormous size because of the lower gravity on Mars and the planet's lack of plate tectonics. Unlike on Earth, where tectonic plates move and shift, creating chains of smaller volcanoes, Olympus Mons was able to erupt continuously for millions of years, building up layer upon layer of lava to form its towering height. In the vacuum of space, no one can hear you scream. It's a classic line from the movie Alien, but it's also scientifically accurate. Unlike on Earth, where sound waves travel through the air, vibrating our eardrums and allowing us to hear, space is a near-perfect vacuum. There's no air to speak of, certainly not enough to carry sound waves, so if you were to blast your favorite song in space, no one would hear a thing, even if they were standing right next to you. That's because sound waves need a medium to travel through, whether it's air, water, or even solid objects. Without a medium, there's simply nothing for the sound waves to vibrate. So, the next time you're watching a sci-fi movie and you hear explosions booming through space, remember that it's just for dramatic effect. In reality, space is a silent symphony of light and motion. Water, the elixir of life, isn't just confined to our planet. In fact, astronomers have found evidence of water all over our solar system and beyond. One of the most surprising discoveries was the detection of giant clouds of water vapor floating in space. These cosmic reservoirs of water are so vast that they contain more water than all the oceans on Earth combined. Now you might be thinking, how can water exist in the vacuum of space? Well, it all comes down to the conditions. In the vastness of space, where temperatures can be incredibly low and the pressure is almost non-existent, water can exist in a gaseous state, forming these massive clouds of vapor. These clouds are often found near young stars. where the heat from the star evaporates ice particles in surrounding dust clouds. Our Sun may seem like a big deal to us here on Earth, but in the grand scheme of things, it's actually a pretty average star. However, that doesn't mean it's not incredibly massive. In fact, the Sun is so large that you could fit over 1 million Earths inside it. That's right, over 1 million Earths. The Sun's diameter is about 865,000 miles, which is about 109 times the diameter of Earth. To put that into perspective, if the Sun were a hollow ball, you could fit about 1.3 million Earths inside it. And if you were to weigh the Sun, it would account for about 99.86% of the total mass of our solar system. The remaining 0.14% is made up of all the planets, moons, asteroids and comets combined. The universe is a dynamic and ever-changing place. It's not just sitting still, it's constantly expanding. This mind-blowing concept was first proposed by Edwin Hubble in the 1920s, and it revolutionized our understanding of the cosmos. Hubble observed that distant galaxies were moving away from us, and the farther away they were, the faster they were receding. This observation led to the development of the Big Bang theory, which states that the universe originated from a single point about 13.8 billion years ago and has been expanding ever since. Now, the expansion of the universe isn't like an explosion where everything is flying apart into a pre-existing space. Instead, it's the fabric of space itself that's stretching, carrying galaxies along for the ride. Imagine a balloon with dots drawn on it. As you inflate the balloon, the dots move farther apart, not because they're moving across the surface of the balloon, but because the balloon itself is expanding.